This video goes over the calculus concept related rates. In this video, we look at the problem, what is the rate of change in the volume of a candle as it burns in respect to time at 150 minutes. To complete this project, we had to run an experiment, and for this experiment, we needed the following materials: 1 lighter, 3 cylindrical candles, a timer, a ruler or tape measure, and a computer with Excel. Moving on to the procedure. First, we measured the initial height of the candle and the radius, which is constant in the volume equation, which will be explained later. Second, light the candle and start the timer for 30 minutes. Once the timer goes off, record the new height of the candle, which is the highest point of unmelted wax, then restart the timer. Repeat steps 2 through 3 for 5 hours, and don't forget to take a video. For this experiment, we decided to take a time-lapse video of our candle burning, as we felt it would show and explain the best on how the candle melts in respect to time. Once we finished burning the candle, we opened an Excel spreadsheet to help sort out our data. We had 4 columns labeled as time, radius, height, and the average change in height, which we used Excel to calculate. After filling out the data, we created a graph showing the data from the height and time. This graph requires axis titles, a logarithmic trend line, the r-squared value, and the trend line equation. This graph shows the rate of change in the height of the candle with respect to time. Now we moved on to the mathematical analysis of the experiment. The equations needed for this are the trendline equation, volume of a cylinder, the derivative of the trendline equation, and the derivative of the volume equation. The time we were interested in finding the instantaneous rate of change for was 150 minutes. To find the change in volume in respect to time, you need to know the change in height in respect to time and the radius constant. We're able to use a radius constant because our radius never changes, so it gets calculated prior to taking the derivative of the volume equation. The radius constant turns out to be 2.640625. Then, to find the change in height in respect to time, you use the trendline derivative and plug 150 in for the t-value. This gives you negative 0.0030933333 as the change in height in respect to time. Now that we have what we need to find the change in volume in respect to time, we solve for the equation. After solving for the change in volume, you should end up with negative 0.02566155757 inches cubed in respect to time. At the end of our experiment, due to the success of our experiment, we can prove that the instant rate of change in volume is negative 0.02566155757 inches cubed at 150 minutes as a candle burns.